Ever wonder why, even though our planet is continually spinning, we don't feel any movement? It's a question that's fascinated humans for centuries, and today we're going to delve into the science behind it. Picture this. Earth, our home, spins on its axis at a speed of approximately 1,000 miles per hour. That's faster than the speed of sound, yet we don't feel as if we're in a constant state of motion. Why is that? The answer lies in the concept of relative motion. You see, we don't perceive movement in terms of absolute speed, but rather in changes of speed or direction. Think about when you're in a car cruising down the highway at a steady 60 miles per hour. You don't feel the movement, do you? That's because your body is moving at the same constant speed as the car. The same principle applies to the Earth's rotation. Our planet doesn't just spin around its axis, it also orbits the sun at a staggering 67,000 miles per hour. Yet, we don't feel this motion because it's constant. We're moving along with the Earth, so from our perspective it feels as if we're not moving at all. But what happens when there's a change in speed or direction? That's when we feel motion, like when your car speeds up, slows down, or takes a sharp turn. It's the change in velocity, not the motion itself, that we perceive. Now imagine if the Earth were to suddenly stop spinning. The abrupt halt would cause everything not attached to the surface to continue moving at the same speed due to inertia. It would be catastrophic. Thankfully, the Earth's rotation is remarkably consistent, and we keep pace with it, feeling no movement at all. So, we can't feel the Earth's rotation because our bodies are moving with it at a constant speed. We're all part of this grand cosmic dance, spinning through space on a planet that never stops moving. Yet, we feel as if we're standing still. Isn't that fascinating? Stay tuned as we explore more about these invisible forces in the next scene. Inertia and gravity, two forces we can't see, play a huge role in why we don't feel the Earth's rotation. Now let's break down the roles of these invisible forces, starting with inertia. A principle introduced by Sir Isaac Newton, inertia is the tendency of an object to continue in its current state, whether it's at rest or in motion. Think of it like this. If you're in a car that suddenly stops, your body wants to keep moving forward. That's inertia at work. In the context of our planet's rotation, inertia keeps us moving in the same direction as the Earth. Because we're moving at the same speed and in the same direction, we don't feel the spin. It's similar to how you don't feel the speed of a moving car as long as it's moving at a constant speed and direction. On the other hand, we have gravity, the force that attracts two bodies towards each other. In our day-to-day life, it's the force that keeps us grounded, literally. It's the reason why we don't float off into space. Now you might be wondering, how does gravity come into play with the Earth's rotation? Well, the Earth's gravity pulls everything towards its center. Without gravity, we'd be flung off into space due to the Earth's rotation. But because of gravity, we stay grounded and don't sense the spin. However, gravity doesn't just keep us on the Earth, it also keeps the Earth itself together. Without gravity, the Earth would disintegrate, breaking apart due to the centrifugal force of its spin. So you see, inertia and gravity work together to create the equilibrium we experience daily. They balance the centrifugal force caused by the Earth's rotation, negating any feelings of movement. Imagine a world without these forces. We'd be constantly thrown off balance, with every step becoming a struggle. It would be like trying to walk on a perpetually spinning merry-go-round with nothing to hold on to. Without inertia and gravity, our experience on Earth would be drastically different. There are more reasons why we can't feel the Earth's rotation, including the Earth's shape and its atmosphere. Let's dive into the Earth's shape first. Our planet is not a perfect sphere, but an oblate spheroid, meaning it's slightly flattened at the poles and bulging at the equator. This bulge is due to the centrifugal force caused by the Earth's rotation. Now you might be thinking, shouldn't we feel this centrifugal force? Well, the effect is incredibly slight, making it essentially imperceptible to us. The difference in gravitational pull between the poles and the equator is minuscule, which further reduces the impact of the Earth's rotation on our senses. Now, let's shift the focus to the Earth's atmosphere. Imagine you're in a car with the windows up. As the car moves, you don't feel the wind because the car's interior, including the air inside, is moving with you. The same principle applies to the Earth and its atmosphere. Our planet's atmosphere moves along with its rotation, so we don't feel a constant wind blowing in our faces that we would otherwise feel if the atmosphere were stationary. This coordinated movement creates a calm environment, making it impossible for us to sense the Earth's rotation through the wind. Moreover, the atmosphere plays a pivotal role in cushioning the effects of the Earth's rotation. The Earth's atmosphere is like a thick blanket wrapped around the planet. It not only provides us with the air we breathe, but also acts as a buffer, dampening the effects of the Earth's rotation and helping to maintain a stable environment. So, the Earth's oblate shape and the cooperative movement of its atmosphere are among the reasons we don't feel like we're spinning at over 1,000 miles per hour. These factors, along with the ones we've previously discussed, work in harmony, creating a stable, seemingly motionless environment for us. The Earth's shape and atmosphere further contribute to our inability to feel its rotation. So, why can't we feel the Earth's rotation? Let's recap. We've taken quite a journey today, delving into the intricate dynamics that allow us to live comfortably on a planet that's spinning at over 1,000 miles per hour. The key to this conundrum has been found in the principle of relative motion. Just as you don't feel the speed of a car when you're inside it, you don't feel the Earth's rotation because you're moving with it. You, me, everything around us is spinning in sync with our planet, making the motion unnoticeable. But the principle of relative motion is just the beginning. Our experience on Earth is also shaped by the invisible forces of inertia and gravity. Inertia, the tendency of an object to maintain its state of motion, keeps us moving along with the Earth. Gravity, on the other hand, pulls us towards the planet's center, creating a sensation of downward force that we perceive as weight. These two forces work together to keep us grounded and oblivious to the Earth's spin. Not to forget, the Earth isn't a perfect sphere. Its oblate shape, wider at the equator than at the poles, influences how we experience its rotation. The Earth's spin causes a centrifugal force that is stronger at the equator, leading to a slight decrease in the pull of gravity. Yet this effect is so minute that it's virtually undetectable to our senses. Lastly, our planet's atmosphere plays a pivotal role. The air around us, just like everything else, moves with the Earth. This prevents us from feeling any wind that would otherwise result from the Earth's rotation. Plus, the atmosphere also protects us from the harsh realities of space, making our lives on this spinning planet comfortable and, more importantly, possible. So there you have it. The interplay of relative motion, inertia, gravity, the Earth's shape, and its atmosphere all contribute to our steady, stable experience on Earth. Despite our planet's constant spin, these factors combine to give us a steady, stable experience